Hello, today we're gonna talk about spanning tree. So, spanning tree it is. Spanning tree. Spanning tree. Um, do you have a computer in here and a server? So this computer will send a packet and it will go to this cable. But what would happen if this cable get destroyed? Somebody cut it. So we're gonna talk about. I'm gonna talk about it like this is a freeway, okay? So what will happen if the freeway is under construction here? Then basically you can't go back to work. This is your work. So in a better way, what we need is we need another highway or alternate route. So I'm gonna create an alternate route in here. Now great. Now we have an alternate route in here. So what happened is if this route is all jammed and under construction, we can always go here. Fantastic, great. Um, but there's a problem with this one. Sometimes when this PC send a broadcast is it means that the packets will be sent everywhere. So it'll be sent in here and sent in here, and then this one will send it back in here. This one will send it back in here because a broadcast will send it everywhere, and it will create sometimes a loop. And when this loop created, it's not very good. Your network will go down. So you don't want to do that. So, so how can we have two freeway to go to our work in case one of them fail? We need the spanning tree. So it's like, here we come, spanning tree. He's gonna save the day. And what he does is he temporarily disable this one when you see two lines in here, so everybody can go here to here. And when this get destroyed, we can use this one. So if this is destroyed, we can go use the other freeway. And that's how the spanning tree works on the very basic. But let's move on because we're gonna get more in detail. Because we're gonna find out how spanning tree chooses which one he wants to disable. He either wants to disable this one or this one. I mean, how does he choose which one? So that's what we're gonna talk about. So let me bring out another picture here. All right. First of all, what they need to do is what the spanning tree does is the first step is find a root bridge or find basically the main place that he wants to go. Pretend the root bridge is Disneyland, so he wants to go to Disneyland, which is the root bridge, and he needs to find the best path or the best freeway to go to Disneyland, and then he needs to eliminate all other pathway or all other freeways that leads to Disneyland because he already found the best path to Disneyland. So in here, let me put this up here. So in here we see that this is the root bridge, and we pick that for now as a root bridge. And so how we gonna go to this one? So first we need to find the perfect path in it. So let's see this. Let's just change this for a second. Let's change this to 100 megabits. Okay. Alright. So if you see in here 100, that's kind of like the pretend is the speed. It's 100, like say pretend it's 100 miles per hour. You can go 100 miles per hour in here, and then you can go 10 miles per hour in here. And this road, you can only go 10 miles per hour in here, and 10 miles per hour in here, 10 miles per hour over here. So this one, you wanna take this road because it takes you a lot faster, because you go 100 miles per in here, and then you can go 10 miles per here. But this one, you go 20 miles both way. I mean 10 miles and then 10 miles, not 20 miles, sorry. So it's a lot faster to go to the other one. So as we were talking, First, we need to find the root bridge, which we found. This is Disneyland for us. This is the root bridge. And the second, find the best path to the freeway. We did find that. We went from here to here to here. So, and then what's the third one is we need to eliminate all other roads. So basically, we need to eliminate this road and this road because I'm going here and here. Okay, and for this switch, see, for this one, how can he go to Disneyland? Basically, he just goes here, or he can go here, here, here. But he doesn't want to do that. It takes a lot longer to do that. So he just want to go straight over here. So this becomes the this is the Disneyland. So he just goes here. Also, we're gonna talk about root port. The spanning tree has a root port. Basically, what's a root port? Basically, root port is basically the best path to go there. So this is your root port. So this has become the root port. Root port for this one. Yeah. So let's see this. Root port. Okay, that's a root port. Let's see. This is the root port. Okay. Root port. Because this is the best path for this switch to get there. Root port. Okay. And for this one, remember we were talking about this one before. His root port is over here. That is root port. Okay. And for this switch, his root port means here. Right. I turn on my navigation. It tells me the best route. And basically, kind of like you think about this. This is the best route. Is to go here. Root port. See? That's your route. So. Okay. And the root bridge, he has this designated port. So this interfaces has the designated port. Okay. So the root bridge always have the designated port. And the reason why this is the designated port is because the root port connects to the designated port. Wherever you're going, your destination will be the designated port, or I kind of think about it as destination port. This is your route and this is your destination port. So for this one, this is the destination port, because you want this as your root port and this is your destination. Root port, destination port, root port, destination port. So I hope that's clear. This one, you kind of block this one. Remember the spanning tree blocked that one because it's very slow to go there. So you block that one. But this still became a designated port. It just doesn't have the root port in here. You don't have any root port in there. You just have designated port in here because it's still a destination. It just doesn't have a route in here. Okay, but you gotta remember that this still has a designation even though it doesn't have a route. So this is designated port, designated port, designated port, designated port. Okay. All right. Now we're gonna talk about. Let's see this. Let me erase everything. Okay. Now we're gonna talk about how do they elect which is the root bridge one. How do they elect the switch as a root bridge? Okay. First of all, every switch in here, they have a root bridge ID of, forgot what the number is. I believe it's 32768. Yeah, that's the right one. So every router in here has a root bridge of 32768. 32768. It was just given to them that their root bridge is 32768. And the lesser your root bridge is, pretending this root bridge is 40, and so he becomes the root port, and you cannot adjust this manually, and that's why it becomes the root bridge. But sometimes you just connect to the network and you don't really adjust it. How does they pick which root bridge it is if everybody is tied on 32768? Well, it finds the lowest MAC address. So this one pretend has the MAC address of, let me see this, let me see this, there we go, of 11111111111, and this let me see this. And this one has a MAC address of 3333333, and this one, oh shoot, sorry, this one has a MAC address of, let's see this, 4444444, and this one has a MAC address of 55555. So you want to go to one. They have the same ID. You're gonna go to the lowest MAC address. Now, if you think about it, if you have the lowest MAC address, basically they're gonna pick maybe the slowest switch, you know. And I don't know why they did that. Maybe because when you have a older switch or something like that, it's more stable. That's why probably they were thinking. Because if probably the higher MAC address be the fastest and stuff like that, but they went for more stability instead of the fastest switch or whatever. But anyways, that's how they pick the root bridge, and the way they identify this is they send out a probe, or they send out a BDPBU. I think that's what they call them. Let me see this. Yeah, so yeah, it's so it is. I'm gonna write down. It's called BPDU. And BPDU means it's called Bridge Protocol Data Unit. That's what it is. So what happened is the BPDU, this switch will send BPDU, and it will go around, and then when he find out the BPDU came back to him, he will tell himself, hey, there's a routing loop. So he's gonna disable something else, you know. He's gonna disable the routing loop, get that off in there, so there's no routing loop to prevent broadcast storm. And in that BPDU, that's how they also elect who's the root bridge, you know. The BPDU contains the ID and also the MAC address of their own router, and it goes around. And these four switches, they elect who is the Disneyland, or who is the, you know, where we want to go, or we want to elect as a root bridge. And when they elected it, and then they figure out what I told you before, how to get there the best way. So basically that's spanning tree for you. Okay, and this is basically the basic of the spanning tree and how they get this. Okay, and it gets more complicated. This one is very simple topology, and it gets more complicated. Let's see if we can do a complicated one. See, this one is a complicated one. Actually, I was working this packet tracer, and it seems like this green one means they're connected. See that? This green one is connected, and I think they what they did in here is this guy actually picked this as root bridge, you know. Yeah, because green means you can go here, you know. You can go here, or you can go here. You know what? Yeah, actually the root bridge is over here. See, the root bridge is over there, because everybody is leading to that switch. So if the root bridge is there, then everybody just needs to go there, and say pretend that this becomes the root port, and this becomes the designated port, designated port, because that's the root bridge. All the port of the root bridge is basically a designated port. Designated port. Designated port. Okay. So if this switch, he already decided how to get there. You can see the green light. So what happened is this one, when I wanna go there, I just wanna go straight over there. And all other ways, I'm gonna disable. See that? See, that's why it's green in there. It's pretty cool. So this is gonna be the routing, the root port, and this is the root port, or RP, and this is the designated port. I say that this is a root port. This is a root port for this guy, and this is the root port for this guy, and this becomes a designated port. Okay, and when this goes over here, I guess he has to go, since this is a root port, he actually have to travel from here to here. There's a way actually in here, it's a lot faster, but since this is the root bridge, he has to go through here and here, because they disabled this one, the spanning tree disabled this one. Yeah, so that's how it is. Okay, so to do it again, if this is, let's see this, if this is the root bridge, everybody goes there. See, everybody goes there. They find the fastest path or fastest freeway to get there, and all other else they disable. So this one, see, they disable this one because disable this one. Even though this is the fastest to go here, we have to eliminate this one, because we have to first, remember what I said, we first need to find the best path and eliminate all other roads. Best path to the root bridge, best path to Disneyland. So that kind of sucks for this, because he can just, from this one he can just send a message in here, but no, since we have to go first to the root bridge to Disneyland, how to get there. Okay, I hope this helps, and on the next tutorial probably I'm gonna do the configuration, but it's really important to know the basic and how the spanning tree works, because if you know the configuration, you can always get them from Google, but to know the idea how it works, it's a lot more better. Okay, and that's how it works. Okay.